Kyle had a curious question. What if we aimed the Hubble Space Telescope at Earth? How detailed would the images be? It turns out, this is a pretty common question. In fact, the Hubble operators hear it all the time. Their fact page even addresses it. Some people assume the issue is that Earth is simply too bright, but that's not the real problem. As Phil Plait of Bad Astronomy has pointed out, Hubble does, in fact, point at Earth occasionally to calibrate one of its instruments. The real challenge: Hubble is just too slow. Let's break it down. Imagine we want to take a picture of an ordinary desk. The light from the desk has to travel through Earth's atmosphere, which can distort images for ground-based telescopes. But for Hubble, which orbits above the atmosphere, this isn't much of a concern. The bigger problem is resolution. Now, Hubble is one of the most powerful visible light telescopes we have, but it has its limits. Consider Pluto. Before the New Horizons flyby, the best images we had of the dwarf planet came from Hubble, and they were nothing more than a blurry smudge. With its current resolution and distance from Earth, a desk seen by Hubble would look just as indistinct. And that's only the beginning of our troubles. The real issue is motion. Hubble zips around Earth at over 7 kilometers per second. From its perspective, any object on the surface of our desk, for instance, is rushing past at the same speed. Taking a clear photo under these conditions would be like trying to snap a picture of the ground from a speeding car. The result? A streaky, useless blur. Could we solve this problem by making Hubble track the surface? In theory, yes. Hubble already swivels to follow distant celestial objects. But here's the catch: its automatic tracking system is only designed to follow things that are at least 10 times farther than the Moon. Even photographing the Moon itself requires special manual commands, and even then, the images aren't great. Now, let's apply that same difficulty to our desk. Compared to the Moon, the desk is moving across Hubble's field of view much faster. But here's the strange part: in absolute terms, the desk isn't actually moving that fast. To keep it in focus, Hubble would need to rotate at less than 1 degree per second, about 1/10 of a revolution per minute. That doesn't sound extreme. Unfortunately, Hubble just wasn't built for this. Its top rotational speed is only a few degrees per minute, about the speed of a clock's minute hand. Even at that pace, its gyroscopes introduce vibrations that would wreck the image quality. Clearly, if we wanted Hubble to track Earth's surface, we'd need a completely different control system. Technically, such a system could be designed. After all, Hubble's rotational inertia is similar to that of a small carousel, so with the right modifications, we might just get it to follow Earth's surface smoothly. In that case, while Hubble wouldn't be able to read the text on a piece of paper, it could at least make out a person rolling around in their desk chair. But here's the kicker: this isn't just a thought experiment. In reality, much of the technology used in military spy satellites is believed to be similar to Hubble's. So, while Hubble itself isn't built to spy on us, satellites with comparable capabilities do exist, and they're already doing exactly what Kyle imagined.